All right. All right, let's just get right into it. So, MDM Hygiene for Mac admins. How safe is your Mac fleet? So, what is this talk going to be about? So first, we're going to give a very brief intro to MDM. We're going to discuss the importance of security. We're going to go over common security pitfalls, specifically those that Mac admins will commonly make. We're going to poke some MDM vendors, and finally discuss future research for the audience. Well, before we get too much into that, who am I? My name is Mykola Grymalyuk. I am the lead security and software engineer at Ripeta Consulting. It's a small IT company out in Calgary, Alberta. Outside of that, I'm also the project lead of Open Core Legacy Patcher. The general idea is how do you get old Macs running newer operating systems for a few more years of life. Finally, I have my blog, chronokernel.com, where I blog a lot of this. My slides will also be on there. But with that, with great power comes great responsibility, and with an MDM server, a ton of ways to break a fleet. So what is an MDM? Well, I'm going to give you the most boring answer I can think of, just stands for mobile device management. But for this talk, it is three primary things. One, it is centralized device management, specifically provided by Apple Framework, so it hooks deep into the operating system. Two, it's normally managed by a third-party service outside of Apple Business Essentials, but we're going to pretend that's not there. And third, it is privileged access, specifically through the install profile command, where you'll get even deeper settings than those of a root user. So with that, why is security important? Most of you already know this, but there are two primary reasons in the modern world. One is, of course, targeted attacks. You're an organization, you have important data, people want to exfiltrate it. But two is automated attacks. You have an endpoint out there, well, someone's going to hammer it and to see, hey, can I break into this just with some random tooling they've got off GitHub? And then looking at Unit 42's report, we actually see that there was a 101% increase in info stealers between the last 2 quarters of 2024. So this shows that the Mac and Mac environment is becoming more widely used and going to become more vulnerable or more targeted. So with that, let's look at common security pitfalls. For this, there are 4 primary ones I'm going to talk about. First is profiles, second is scripts, third is software catalogs, and finally enrollments. So let's move to profiles. With profiles, there are 3 main ones I want to talk about today. There are many more that you can misconfigure, but for these are the fun ones that I see most often out there. So the first is full disk access, second, background tasks, and third, gatekeeper. So with full disk access, let's take this vendor application we have. This vendor application needs to be deployed to all our endpoints. However, this vendor application has an annoying prompt for the desktop, for the downloads, for documents, so on and so forth. So what do? Well, you're going to push a full disk access profile. So the com.apple.tcc configuration profile policy with the system policy all files. And what this means is that the application will get all those access to all those folders and much more, and your users aren't going to be prompted. So what's the issue with this? Well, apps with arbitrary code execution, and looping in last year's talk with Lexicus, we can see a similar issue where if, for example, you give Discord full disk access and then you run arbitrary code through Discord, well, now Discord doesn't just have access to your documents or your downloads, it also has access to your calendar, your photos, your contacts, and so on. The other one I've seen people push full disk access to is ZSH and Bash. Commonly with different types of tooling, but sometimes it'll be with system setup, where set remote Apple events needs to have full disk access to run. So then, how do we change this profile to be a bit better? Well, we're going to carefully scope it, so it only give the application what it actually needs. Don't give it full disk access. Don't let it have fun with your machine. The other thing to think about is, do you generally need to do this for your applications? So while yes, TCC prompts are annoying, prompt fatigue is a problem, but if an application is only going to prompt once on a fleet of 1,000, maybe you don't need to push that profile. And then the other thing is for ZSH and Bash, can you scope your profiles accordingly to configuration time? So when, for example, you're enrolling a new device, only push that full disk access profile temporarily. Once it's configured, pull it. So next, let's look at background tasks. So we'll bring in back our vendor application, and now this little utility will install some helper tools. So an XPC service, some updater, all the fun stuff. And as it does this, you're going to get more prompt fatigue, specifically prompts saying, hey, this app is going to be running in your background. Okay, so what we'll do instead is push a com.apple.service management profile and set the rule value, the rule type label prefix with rule value com.malware, or whatever the vendor's app is named. So why is this a problem? Well, spoofing identifiers. So when that application installs its service, it has different properties that can be associated with it. So of course the service's name, the label, but also other properties as well. And so for label, you can actually spoof that, or a malicious application can pretend to be another piece of software because Apple doesn't control the identifier there. So here we see with label prefix, we can see other possible values: bundle identifier prefix, label prefix, and team identifier. However, those first four are actually relatively easily spoofable. So the one you want to be pushing is team identifier. So if we look at our profile here, how do we fix it? Well, we're going to switch it to a team identifier and specify the team ID. Therefore, we're only going to allow or have this profile suppress notifications based off of this team ID because it's much more difficult to spoof. However, you still have to deal with arbitrary code execution because, for example, if you have Discord and you're able to have it execute code on your behalf, well, the team identifier is going to be Discord's. Then we have Gatekeeper. So, of course, you've pushed this application once again to your environment, but unfortunately it has that annoying prompt that you can't open it. Okay, let's do a quick Google search. Let's just disable Gatekeeper. We'll push the com.apple system policy.control. So what's wrong with that? A lot of things. For those who are unfamiliar with Gatekeeper, it's in a sense you can think of it as your first line of defense against unsigned code. And so if you're allowing code that you're not approving of to get through on your machine, bad actors are going to abuse that much more. So how do we fix this profile? We burn it to the ground. We do not, if you can, do not disable Gatekeeper. Something you can do is also educate the developer of the application saying, hey, we need your software signed and notarized. The other thing, you can also take on that onus yourself and sign that software, but that gets pretty ugly pretty quick. Next, let's look at scripts. For scripts, there are two primary vulnerabilities I see. First is working in unsafe directories, and the second is dirty environments. So for unsafe directories, I'm going to pull up a QNAP CV I worked on. So when you install QNAP software, you'll get a QNAP updater under Privileged Helper Tools directory. How this tool works is, one, it is given a disk image. Disk image mounts and looks for a PKG. It verifies the signature of that PKG that, hey, is this actually QNAP software? The PKG or the tooling will copy the PKG into a temporary directory. And finally, we'll install the disk image, or install the PKG. So what's wrong with this process? Well, it's that working directory that it's in. So if we take here a sample bash script, or a ZSH script, we can see here it's going to do a similar work to what QNAP was doing. So we're going to mount the disk image, we're going to copy to temp, and then install it. So the problem here is that, one, we're working in /temp. Anyone can write to that directory, not just root users. And then, of course, then you're installing that PKG with root. So then if we use an exploit, or not a vulnerability, but an exploit method through MV and CP, when we copy from A to B, if a file at B already exists and you copy over it, B will retain the original file permissions. So you can actually copy over or have a malicious PKG at B, copy over, swap it out with malware, and you're off to the races. So if we wanted to fix this ZSH script, we'd want to look here when we're copying it. So instead, we're going to make a personalized directory that we know is going to be root owned, and then install from that directory. So there's less chance of vulnerabilities. One funny thing is, as you probably know, you don't need to copy a PKG out of a DMG. So this was actually how QNAP solved the vulnerability, is just removing the copy step outright. Now let's move on to dirty environments. So we'll bring in another CV I worked on, one related to PackageKit itself in macOS. So for this, you have a PKG that installs as root. Pretty straightforward. Inside of it, there's a pre or post install script with hashtag bin/zsh. Okay, pretty straightforward. Well, when it loads up that script, it's also sourcing an environment file. Okay, seems fine enough for a shell script. Well, the problem is a PKG is installed as root, but a user-owned file is loaded. So what does that mean? Privilege escalation. So how do we prevent loading dirty environments with shell scripts? So of course I have common shebangs there, CSH, bash, and sh. So to solve the issue, it'll depend on your interpreter, but of course for ZSH it's -- no RCS, for bash it's no profile, no RC, and for sh, even though this is just a symlink towards whichever shell you have configured in your operating system, if the executable is named bin/sh, it's not going to load external environment files. Another thing you can do in your scripts as well is not just change your shebang, but also change the executables you're invoking. So a lot of the times we'll rely on path to load up an executable, so like mkdir, codesign, MDM client. Well, if we can specify that full path, there's even less a chance of that application getting swapped out with something malicious. So for example, you can run where mkdir in terminal, and it'll actually give you the full path of the executable. And if you have multiple ones on path, you can select the one you actually want. So if you look here at the CSH script, how do we fix this to avoid loading unsafe environment files? So we'll add -- no RCS at the top, and then we're going to change the paths for HDI util, mktemp, cp, and installer. Now let's move to software catalogs. For software catalogs, it's a pretty boring one, it's a pretty straightforward one, but it is outdated applications. So for outdated applications, I'm going to use a FortiClient CV I worked on. So for this, we have your, let's say your managed software center or some kind of system that you are using to install applications. And here you're going to install FortiClient. Okay, pretty straightforward. Well, the problem is FortiClient's outdated. And so through the installation, not the presence of FortiClient, but the installer itself, you're able to get privilege escalation in. And so now this install is compromised, and any updates after that aren't going to be perfect because you got to remediate that machine specifically. So what are the best ways to handle these issues? There's three primary ones. If you can use MDM provided apps, so using ones that the MDM themselves are going to manage, keep updated. My personal favorite is using Monkey and Auto Package, building your own pipelines to make sure your apps are up to date. And the third one, and the one I feel is most useful for smaller organizations, is using either Root3's app catalog or Electrona Patch. These are, in a sense, they're not Monkey, but you can think of them as like a service that will manage these apps for you, and they're MDM independent. So you can push this into any MDM you want. So now let's look at enrollments. For enrollments, there's only one fairly obvious one. It is weak/missing authentication. So with weak and missing authentication, the general issue is this. You have, there is a malicious machine somewhere in the world. Well, this machine is trying to get into your MDM itself. And then without any authentication, it's just an open door for that machine to be enrolled. And depending on how you have your MDM set up, you'll just push all your things. You'll push your Wi-Fi, your Wi-Fi credentials, certificates. You'll get access to all the software catalogs, build custom CVEs to a specific company, as well as getting additional developer tooling. So how do we fix this? This is going to be more MDM dependent, but the general idea is this. Implement authentication as well as quarantining when you can. If a machine is not something you recognize, try to hide it away, don't give it the resources it needs, and figure out, is this actually an employee BYOD or an actual problem? And based off of this, let's query some MDM enrollments. How do we actually find these unauthenticated enrollments? So I developed a utility called Project Indigo. And the utility works on Mosel, Jamf Now, and Simple MDM. The general idea is it's going to just generate random numbers and figure out, hey, which ones are valid enrollments? And then based off that, query a bit further and see, hey, is there authentication? Are we actually able to get in and download profiles? The utility itself is on GitHub. It's just there for educational purposes. It's not meant to be used in a malicious way. I also have a QR code here. There's going to be a QR code at the end of the slides as well. But let's look at how Simple MDM works. So for Simple MDM, their old URL was a.simplemdm.com/enroll/c C equals all those identifier, all those characters. So the identifier format is 8 characters, integers only. This is a brief sample so you can see what they look like. And Simple MDM offered 2 types of authentication methods, none or SAML. Okay, that's not horrible. At least we have some way to lock it down. What we recommended was implement URL complexity. Like this URL is too easy to brute force. We couldn't find many different clients. Implement challenges. So like we all hate CAPTCHAs, but they do prevent or do help limit bots hitting your system. And as well as implement a passcode. Not everyone has the infrastructure set up to be able to handle SAML. We notified them in September of 2024. And so what was the fix? Well, they actually added URL complexity, so it was much more difficult to brute force. However, there is a small caveat. It's still vulnerable on existing enrollments. You have to go into your Simple MDM enrollments and actually manually update the URL to be a larger randomization. So then we'll look at Jamf Now. So URL go.jamfnow.com, and then you got your identifiers. The identifier format itself is 6 characters. It's integer, uppercase, and lowercase. Brief sample there. And the authentication method is only a passcode for the generic Jamf Now, but it is required. It's not optional. So that means you have to brute force even more digits. So what we recommended was more URL complexity, as well as implementing challenges to make it more difficult to brute force. And we notified them in January of this year, and their solution? Nothing. To be fair, you already have the passcodes in place. They didn't feel that it was important enough to implement more complexity in the system. And especially then you would go to Jamf Pro if you wanted more intense setup in your system. Finally, we'll look at Mosel. So the URL is join.mosel.com, and then of course your identifier. The format itself is 6 characters, integers, and uppercase letters. Brief sample there. And the authentication methods that were available were none, SAML, or you could give a pre-approved device list based off serial numbers, if I remember right. And the recommendations we had was, of course, URL complexities, challenges. However, something that really terrified us with Mosel is that every single device group you created had codes generated. So even if someone didn't realize they had enrollment channels open, if you had like 20 device groups, you had 20 enrollment channels that everyone was open to if you had enrollments enabled for one. So we notified in September of 2024, and their solution mostly was to disable unused enrollments after 90 days. This isn't horrible, but the problem is it's still dead easy to abuse. If you have used your enrollments in the past 90 days, well, all your device groups still have enrollment codes. So based off of this, what about other MDMs? The ones I tested were the ones that I could easily get access to. Of course, Mosel and Jamf, I didn't need to do anything for the account really. I think we already had them at work, same with Simple MDM. But for this, the general idea is pretty straightforward. You enable developer tools, you'll follow the URL and figure out, hey, how can you follow this through to be able to, for example, curl it, or in my Python library, be able to download it and hit it over and over to figure out which one's a valid code. Now let's wrap up. So of course we looked at profiles themselves, full disk access, background tasks, gatekeeper. With scripting, we looked at vulnerable or unsafe directories, dirty environments, software catalogs, outdated apps, and enrollments with weak authentication. The interesting thing is, even after all the reporting we did, this tool is technically still valid for all three clients, or for all three platforms. So do with that what you will. Otherwise, thanks for listening to my rambles. I have one more slide after this, references. Those are linked on the QR code there.
Any questions? Friday the 13th is our scary day. Thank you, Mykola.
Thank you.
Okay,
This is just a quick question. Back to the specifying the paths when you're calling binaries. So obviously you're highlighting the security purposes. Is there also just a usability issue in terms of, like, let's say there are multiple binaries that live in different paths and maybe they operate slightly differently? Is that also part of specifying what path you want?
So exactly that. If you've ever fought with Homebrew when pushing your scripts to endpoints, it's exactly that. You can at least specify the system binaries that you know that are Apple binaries and are mostly replicable across machines.
Sorry, I turned it off.
Is it, there we go. So the other comment to the follow-up of that is two parts. On macOS, it probably doesn't make sense to use Bash as a scripting language because it's a couple of decades out of date if you're worried about security. And the other one is that the opposite of what you're saying is if you're using Brew, you may want to use hardpass to avoid using Apple's binaries. Too, because you're getting a newer version of what Apple is pigheadedly not updating their executables for.
That's an interesting way to look at it. Generally, at least in our environments, we don't trust Brew because normally what we would see is just users would install Brew without us knowing. So of course, Work Brew would be an easy solution to this. But related to ZSH and Bash, specifically about it being outdated, Apple is still pushing security updates to it. I have found vulnerabilities in Bash, and they have fixed it in questionable ways. But based off that, like, you should be moving ideally to ZSH, or if you want, Fish.